Hey guys, welcome back. I'm going to do some examples for you today in your nuclear chemistry independent practice. There are only 5 problems here. I'm going to do the first 2, so you have an alpha example and a beta decay example. And then your last 3, you should just be able to use this video and follow the process step by step to do it. Now, nuclear chemistry can be a little bit tricky, especially if you have forgotten some of the stuff that we have learned in the beginning of this class. So please just make sure you're following along, and if you have any questions, you let me know, because we are going to have to call on not only the new stuff that we learned today, but also some stuff that we learned in our earlier lessons as well. So you will need p-table today, and so I have it linked here for you. It was also linked in your assignment, but you just want to make sure you have it pulled up, because we're going to have to be getting our atomic number from some of these elements today. Okay? So we're doing alpha and beta decay. There are no gamma decay problems here because it's kind of, it doesn't mean anything in terms of what's happening with the atom. Because remember, with gamma decay, you are just kicking off energy from the atom of, or the nucleus of whatever atom we're talking about, and it doesn't actually change the element itself. So we're going to get some practice with alpha and beta where the element is actually changing. So remember, gamma decay, all that's happening is that we're releasing that high energy from the nucleus, and nothing's actually changing about the identity of the atom. So let's do the first one. It says the alpha decay of radon-198. Well, the first thing we need to recognize is that radon-198, that's an isotope, right? That means that this element's atomic mass is 198, because when we have the element dash this number is the atomic mass, right? So we know that. And we also know that this is undergoing an alpha decay. So that means we're going to lose the equivalent of a helium nucleus from the inside of the atom. Remember, the atom has the protons and the neutrons in the middle, and then the electrons outside. We're talking about the protons and the neutrons in the middle here that are shifting. So radon-198 is essentially going to lose a helium atom, and we have to figure out what new element is going to be formed by that. Okay, so let's go ahead and start with what we know, which is we have radon-198. So I'm going to put the nuclide symbol in here so that we can see it a little bit easier. So I'm going to go to Insert, and I'm going to go to Equation. And you should see these functions up here. We want a math operation and we want a fraction, okay, because we're going to put our nuclide symbol, which is the fraction. So we have 198 as our atomic mass. Now let's go find radon on the periodic table, and let's find his atomic number. Okay, so let's find radon. Remember, you can always search right here if you need to. So radon is right here. So radon has an atomic number of 86. Remember, the smaller number in the box is always the atomic number. It tells you the identity of the element, and it tells us how many protons we have in the nucleus. So radon is 86. So I'm going to come back, and I'm going to put my 86 on the bottom. Okay? And the elemental symbol is Rn. Okay, so that's what we're starting with. Now I'm going to go to Insert Special Character, and I'm going to get my arrow, my rightward arrow, and we've got to figure out what is being lost. So we know it's going under alpha decay, and anytime an element undergoes alpha decay, that means it's losing an atomic mass of 4 and an atomic number of 2. Okay, so I'm going to do the same thing I did with my radon and just demonstrate that here in the equation. So I'm going to go to Insert, Equation. You want another fraction. And again, we're losing 4 atomic mass, and we're losing 2 of the atomic number, right? So this is what we're losing in alpha decay. This is the equivalent of a helium nucleus. So we write He to show that basically radon is losing a helium atom, okay? Now we have to figure out the new element that's formed. So let's go ahead and do our same thing. Let's insert our equation. And we need another fraction. Now, to do alpha decay, since we're losing an atomic mass of 4, whatever mass is right here with our element, so it's 198 for this radon, we'll do 198 minus 4. So 198 minus 4 will give us 194. And then the bottom one, 86 minus 2. Okay, so 86 minus 2 is 84. Okay, so we're showing now that we've lost the alpha particle and we have created, or we have decayed, this is decayed, into a new element. Well, now we have to figure out what that element is because it's decayed into a different element. And it doesn't have an atomic number of 86 anymore, it has an atomic number of 84. And we know we can identify elements by looking at the atomic number on the periodic table. So let's go back to our table and find our atomic number of 84, which is polonium. So we're just going down 2. And so polonium will be our new element. So PO is what we're going to write here. Polonium. That is your alpha decay of radon 198. So radon 198 undergoes alpha decay into polonium 194. Okay, so the nucleus of that radon kicked off a helium atom and it gave us polonium 194. Okay, so you will use this example to help you do number 3 and number 5 as well. Okay, so now let's do 2, which is the beta decay. So beta decay is a little bit different because we're not going to actually be taking away the atomic number, or we're not going to be subtracting anything from the atomic number. We're actually going to be adding to it. Because remember, in beta decay, a neutron is going to decay into a proton in the nucleus, and we're going to kick off an electron. Okay, so let's do this one really quick. All right, so we've got uranium-237. So we're going to start with what we know. We're going to insert our equation. We need a fraction so we can do our nuclide symbol. So we have 237 as our atomic mass. And let's go to our table and find uranium. Uranium is down here. It's got an atomic number of 92, right? So its atomic number is 92. So we'll put a 92. And its nuclear symbol is U, so we'll just do a U, okay? So now it's going to undergo a beta decay. So I'm going to go to Insert, Special Characters, Arrow. And we know that we're losing an alpha particle, or not, I'm sorry, a beta particle, not an alpha particle. We're doing beta decay. So we're going to insert our equation. So now the symbol for a beta particle is 0, -1, oops, 0, -1, and then an E. Okay, that's the symbol for losing a beta particle because, again, we are not losing anything in our atomic number because instead of losing a helium atom here, what we're doing is that neutron in the nucleus is decaying into a proton. Okay, so this one's a little bit more tricky. But what we just need to know is that for the beta decay, instead of subtracting from our atomic number, we're adding 1 to it, okay? So we are adding to the atomic number. So now we have to figure out what our new element is. Because both alpha and beta decay, we will get a new element at the end of the decay. So let's do our fraction. Okay. Beta decay, nothing changes with the mass, okay? We're not losing any mass in the nucleus, Yes, a neutron is being changed into a proton, but remember, neutrons and protons have the same atomic mass, so nothing's changing with our mass. So we're still going to have 237 as our atomic mass of our new atom, okay? Now, here's what's different about beta decay. It's easy to look at this and say, oh, I'm supposed to subtract 1. No, we add 1. So with beta decay, we are adding because a neutron is decaying into a proton. And remember, protons determine the identity of the atom. So we need to make sure we're paying attention and doing this correctly because you'll get it wrong if you subtract, okay? Alpha decay, you're subtracting. Beta decay, you're adding to the atomic number only, okay? So instead of 92, now we're going to have 93 because we're going to add 1 to our atomic number. So now, like we did before with our alpha decay, we have to figure out what our new element is. Because remember, protons, atomic number tells us the identity of the element. Our atomic number is no longer 92, so that means this is no longer uranium. So let's go to the periodic table. And let's find the atomic or the element with the atomic number of 93, which is going to be, I'm going to exit out of this really quick so we can see. So the atomic number 93 is neptunium. So neptunium, Np, is going to be our new element. Okay? So that is beta decay. So you will use this example in number 2 to help you do number 4. Okay? So just remember, so your equations should look exactly like this. You only have to do 3 of them, 2 alpha decay, 1 beta decay. Now remember, for alpha decay, you are subtracting 4 from the atomic mass, and you are subtracting 2 from the atomic number to give you your new element. For beta decay, the top number, so your atomic mass, stays the same. The bottom number goes up by 1. Okay, so for beta decay, you add 1 to the bottom. For alpha decay, you subtract 4 from the top, subtract 2 from the bottom. And in both of them, you are going to use the new atomic number, which is the number on the bottom, to help you identify the new element. Okay? So go ahead and do your 3 practice problems, and if you have questions, let me know.